Hello everyone. We will learn about a substitution nucleophilic bimolecular reaction, SN2 reaction. It is a type of nucleophilic reaction where a lone pair of electron from a nucleophile attacks an electron deficient electrophilic center and makes bond with it, leaving behind what may be called as leaving group. So the leaving group is replaced by the incoming group in the very first step. Such reactions are named as bimolecular nucleophilic substitution because two reacting species are involving in the process. It is a slow and rate determining step. The slow step involves both the alkyl halide as well as the nucleophile, so that it is a bimolecular reaction. The two molecules determine the rate of the reaction. In SN2 mechanism, the reaction goes in one stage. That is, SN2 mechanism involves only one step. It involves the attack by X, that is X here, X is the nucleophile, on the species YZ, which can be an alkyl halide. The kinetics are now second order, the rate being proportional to both concentrations, proportional to concentration of the nucleophile as well as alkyl halide, so that it is a second order reaction, second order mechanism. When the nucleophilic agent is the solvent itself, there is no kinetic difference between the two mechanisms, SN1 and SN2, since the order is 1 in both cases. The initial ionization is usually referred to as unimolecular, but it is recognized the solvent molecule may also play an important role. There are two important stereochemical differences between the products of reactions in the two cases. Consider, for example, the hydrolysis of an alkyl halide in which the halide X and three different groups are attached to the carbon. If the reaction occurs by SN1 mechanism, the ion C R1, R2, R3 will be formed, and this will tend to have a planar configuration. When this ion reacts with a water molecule or a hydroxide ion, there will therefore be an approximately equal chance of hydroxyl group become attached to each side. Resulting alcohol will therefore be a racemic mixture. That is, the carbocation will be approached by the nucleophile on both sides, from the top end and from the bottom side or bottom position. So we will have two different alcohols, that is a plus alcohol as well as minus alcohol, two isomers, which rotate the plane of the polarized light in opposite direction. So these two in equal proportion is called as a racemic mixture. The racemization may not be quite complete, since the environment may not be the same on the two sides of the ion. The halide ion, for example, may be held by electrostatic attraction to the front side. The results of the reaction may therefore be that it preferential of one stereoisomer. The point is, the leaving group, the halide ion, will not get removed or will not leave the carbon atom as soon as the reaction starts, but it will be there for some time so that the bonded electron would be withdrawn. As long as the time takes for withdrawal of the electron or complete dissociation of the leaving group, the incoming nucleophile have only possible way to attack the carbon atom from the rear side, not from the front side, because at the front side we have the leaving group with the electron. So at these moments, when the leaving group is still attached with the carbon atom, or the leaving group is in some interaction with the carbon atom, at these points the only possibility for the incoming nucleophile to approach the carbon atom is from the rear side, so that these possibility or these results may be, therefore there is a preferential for formation of one stereoisomer than the other. That is, the stereoisomer with the inverted configuration will be formed in major quantity compared to that of the other one. The isomer with retention of configuration will not be formed that much. In SN2 mechanism, on the other hand, what we have seen in the previous slide, it is with respect to the SN1 mechanism, because it is a carbocation mechanism. In SN2 mechanism, the attack by the nucleophilic agent is at the top face of the carbon tetrahedron, that is opposite to the halogen atom. The result is therefore inversion of stereochemical configuration. Such an inversion is often known as Walden inversion and may be represented schematically as follows. This is SN2, where the reaction involves only one step, single step. The nucleophile attacks the carbon atom from the rear side, and from the front side the leaving group leaves. So the obtained alcohol or the obtained product on comparison with the reactant alkyl halide will have a configuration exactly opposite. So here what we say is the molecule is being inverted. The molecule alkyl halide with respect to alcohol in the product, both of them have inversion of configuration. The position that was occupied by the halogen is not occupied by, or it is not occupied by the incoming nucleophile alcohol, OH minus in this case. So these two have exactly opposite configuration, so it is called as a Walden inversion. Examples of a SN2 reaction: bromoethane reacts with a OH minus hydroxy anion, resulting in a transition state, and thereafter it is converted into form ethanol plus bromide anion. This is an example for a SN2 mechanism. Further we will discuss further into SN1 and SN2 mechanisms and their evidences in the next video. Thank you.